So direction cosines and direction ratios of a line. So in space, any line given, that line direction cosines and direction ratios, how to find it? So right, Sima, if we take one rectangular coordinate system, okay na, okay, rectangular coordinate system means here x axis, y axis, z axis. Now this is horizon. So first we take one rectangular coordinate system. Now here if we take one directed line, that directed line passing through the horizon means, so this is the directed line L passing through the horizon. Now this directed line making the angles, makes the angles alpha, beta, gamma with coordinate axis x, y, z respectively. Means what ma? Here first this directed line making the angle alpha with x axis, beta with y axis, gamma with z axis. Okay na? Now if we take one directed line, the directed line passing through the horizon in a rectangular coordinate system. Now the directed line making makes some angles alpha, beta, gamma with coordinate axis x, y, z respectively. Now these angles, which angles made? That angles are said to be direction angles. Direction angles. Now these angles are said to be direction angles. Now these direction angles we calculated in terms of cosine function, means cos alpha, cos beta, cos gamma. These direction angles we calculated in terms of cosine function, cos alpha, cos beta, cos gamma. Now these angles are said to be, these values are said to be direction cosines of the given directed line, direction cosines of the given directed line. Okay na? Now these direction cosines simply we denoted with the letters L, M, N. L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. Now here see ma, just in a rectangular coordinate system, if you draw one directed line that is passing through the horizon, now the directed line making some angles alpha, beta, gamma with coordinate axis respectively. These angles are said to be direction angles. These direction angles are we calculated in terms of cosine function. Now that values cos alpha, cos beta, cos gamma are said to be direction cosines of the given directed line. Okay na? Now in this direction, if we find out the direction cosines of this directed line, now if we extended, so this directed line in this direction, so if we extended this directed line in this direction, now see we take the direction here. Now what is the direction cosines of in this direction of the directed line means, here see here also some angle there are, some angle there. So when if we reverse the direction of the directed line, now this directed line direction upwards there. Now if we take in this case means when we reverse the direction of the directed line, then the direction angles can be replaced by their supplementary angles. Already we know the term supplementary angle means what? Sum of the any two angles is equal to 180 degrees. Then each angle is said to be supplementary angle of the other one. Okay na? So now here see my direction angle how much there here? Suppose alpha there. Now if you, with respect to x axis, if you consider means this is what we consider here, pi minus alpha. So here that imagination difficulty, already I told starting only, this is the three-dimensional geometry, means imagination totally figures. So that's why simply we drawn one x axis here, like this is the x axis. Now if we take one directed line passing through the horizon, means this is the directed line. Now here angle we consider first in this direction alpha. Okay na? Now if we extended this line like this, okay, here extended no like this, we extended this line, directed line. Now this direction is this one. Now this angle how much here? So this angle compulsory pi minus alpha or linear pi. So that's why we used that word here. This is the direction angle that corresponding supplementary angle what no? Pi minus alpha. So that's why this is the pi minus alpha. In this direction, the directed line making the angles with coordinate axis, x-axis pi minus alpha. Similarly, like that only we consider means x-axis pi minus alpha, y-axis pi minus beta, z-axis pi minus gamma. Now these are the direction angles in this direction of the directed line. Now if you want to find out in this direction cosines, these angles are also we calculated in terms of cosine function, means cos of pi minus alpha, cos of pi minus beta, cos of pi minus gamma. Then what we done here? Minus cos alpha, minus cos beta, minus cos gamma. Here see minus L, minus M, minus N. Here if we get another pair, when if we get another pair, when we reverse the direction of the directed line, then automatically the sign of the direction cosines is also reverse. The sign of the direction cosines is also reverse. In this direction cosines, what we find out? L comma M comma N. When we reverse this direction of the directed line, then what is the direction cosines of this directed line? Reverse, means here positive there. Here if we get the value negative. Okay na? So right, one point we remember in space, any directed line we consider, the directed line has two sets of direction cosines. Means what were the direction cosines here? Plus or minus L, plus or minus M, plus or minus N value. In space, any directed line, if we consider, the directed line has two sets of direction cosines, plus or minus L, plus or minus M, plus or minus N. So these direction cosines are unique. These direction cosines are what unique. Right, here some formulas there. Any two vectors given, if we find out the two vectors having the direction cosines and the direction ratios, then what is the angle between the two vectors? Already we learned this concept in vectors also. So right here see first angle between, first point angle between two vectors A and B, two vectors A and B, whose direction cosines are L1, M1, N1 and L2, M2, N2 respectively is, what we are here, angle means cos theta is equal to L1, L2, M1 plus M2, N1, N2. So now this is the angle between the two vectors. When we applying this formula means the two vectors having direction cosines, How do we get this value means simple. So first here two vectors there so two vectors direction cosines given. So that's why you consider here unit vectors. So A cap is equal to unit vector along A bar. So unit vector along A bar is equal to L1 I cap, M1 J cap, N1 K cap. And similarly B cap is equal to unit vector along B bar is equal to L2 I cap, M2 J cap, N2 K cap. Okay na? Now in this direction, vectors direction, if we take the two unit vectors, now let theta be the angle between vectors A bar and B bar. Now we consider the angle theta be the angle between A bar and B bar. Then theta is also angle between A cap and B cap. A cap and B cap. Okay ma? So now what we done here, angle formula cos theta is equal to A cap dot B cap by magnitude of A cap into magnitude of B cap. So A cap dot B cap, already here A cap B cap there nama. So that's why what we replace dot product already we learn in vectors. So I dot I is equal to 1. So that's why numerator value L1 L2 plus M1 M2 plus N1 N2 by 1 into 1. Then finally what we are done here, cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Okay na? Otherwise if you want sine function, sine angle, then what more? First we find out the cos and we applying the identity, sine square theta plus cos square theta is equal to 1, sine square theta identity we applying, then we find out the sine value. Okay na? So next point here, see ma. So next point means in that point only one condition there ma. So now these two vectors are perpendicular. These two vectors are which type of ma? Perpendicular. Then condition what here? If A bar is perpendicular to B bar, then what we are on condition L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Okay na? Is equal to 0. When the two vectors have the direction cosine, the two vectors are perpendicular to each other, A bar is perpendicular to B bar, then condition what ma? L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Otherwise here these two vectors are parallel, means ma A bar is parallel to B bar, then condition what we are done here, L1 is equal to L2, L1 is equal to L2, M1 is equal to M2, N1 is equal to N2. So these are the conditions for perpendicular and parallel condition when the two vectors have the direction cosines. Okay na? Similarly ma, one condition there, second point we remember ma this one, note 2. So then, so again two vectors A bar and B bar, the two vectors have the direction ratios. Here direction cosines given no ma, direction ratios. So means what we are done here, direction ratios of vector A and the direction ratios means A1 comma B1 comma C1 or direction ratios of vector A bar. Next A2 comma B2 comma C2 or direction ratios of vector B. So generally how do we represent this vector? A bar is equal to A1 I cap, next B1 J cap, C1 K cap. Now B bar is equal to A2 I cap, B2 J cap, C2 K cap. Here also same. So direction ratios given, if you find out the angle between two vectors, then formula what we run here, cos theta is equal to A bar dot B bar by magnitude of A bar into magnitude of B bar. Here what my dot product, again same, here dot product means what we run here, A1 A2 plus B1 B2 plus C1 C2 by, here see ma, magnitude of vector, square root of A square plus B square plus C square. Already if you learn any one vector given that magnitude, how to find it, sum of the squares of the scalar components. Here also what we have done, square root of sigma A1 square root of sigma A2 square. So this is represented the angle between two vectors when that direction ratios given. So one point we remember, whenever if you find out the angle between two vectors or two vectors, then doesn't we applying the modulus value. Why means here particularly he doesn't given that theta is acute obtuse. So that's why generally if you run without modulus these values in vectors angle. Okay na? Otherwise three dimensional if you consider means there must and should be applying. Why means there we applying the acute angle. So theta he particularly mentioned acute angle, then we applying the modulus for that angle. Otherwise directly if we applying it without applying the modulus, we find out the angle between that two vectors values. Okay na? Right here see ma, if you find out the, if you find the angle between the two vectors when the two vectors have the direction ratios. Now related this point, if we define another 2 points ma, here what we define means ma, if A bar is perpendicular to B bar, A bar is perpendicular to B bar means vector A is perpendicular to vector B, then condition what we done means here. So means particularly A bar is perpendicular to B bar means dot product is equal to 0, means angle between the two vectors is equal to 90 degrees. Here 90 if you means this value becomes 0, that value taken on to this side. Then condition what here, A1 A2 plus B1 B2 plus C1 C2 is equal to 0 value. So another one parallel. If A bar is parallel to B bar, then what written condition means proportional condition. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So already we discussed these conditions in vectors also. When vectors given, if you find out the angle between direction cosines and the direction ratios related with the, if you find out the angle between two vectors and the related conditions, perpendicular and parallel conditions. Okay na? In 3D geometry, another part ma, so lines, straight lines in a space. Next part what ma, planes there, two parts there. So straight lines in a space. So whenever ma in space, if you take any straight line in a space, a straight line is inequally determined. That straight line inequally determined two conditions. So equation of a lines. So which type of one means ma, first one, that is passes through a given point. That straight line is passes through a given point and has its directions. Means at that case, if you run the equation of straight line in vector form, R bar is equal to A bar plus lambda into B bar. Okay na? In space, a straight line is inequally determined. These two conditions. First one, equation of a line passing through a given point and has a direction, means and is parallel to the vector B bar. Next another one ma, equation of a line passing through a two given points. Then what we prove that ma, here vector form R bar is equal to A bar plus lambda into B bar minus A bar. Okay na? So these two very important theorems ma, for board 5 marks questions. Okay na? Now one by one if you prove the proofs. So first one what given ma, R bar is equal to A bar plus lambda into B bar. So ma, this question how to given in exam means ma, if you remember this is theorem type, theorem 1. So theorem 1 ma, this one statement is given ma, find the equation or derive the equation of a line in space, equation of a line in space passing through a given point, A, equation of a line in space passing through a given point A, x1, y1, z1 and parallel to the given vector, B bar, in both vector and Cartesian form. Ma, very important ma, 5 marks question, repeated question in board. 5 marks repeated question in board ma. So very important theorem. First theorem what ma here, derive a equation of a line in space passing through a given point and parallel to the given vector B bar in both vector and Cartesian form. Right, Sima? First we want to draw the diagram. So now if we take rectangular coordinate system x, y, z axis. Here what given ma? The line, if you take one line, that line passing through the given point. So that's why if you draw one line, so this is the line L. Okay na? Now here A point there, if you passing through the one point and parallel to the vector. If you take one vector ma, this one B. Okay na? If you take one arbitrary point P, what ma? P. Now if you join these points with the origin, now if you join these points with the origin, now this is the direction. So this is a position vector R bar, this position vector ma, A bar. Okay na? So first if you draw the one line passing through the point A and parallel to the vector B bar, and we consider, or if we take one general point, arbitrary point on the line P. Now these connected with the origin, then that is represented A bar and R bar are the position vectors of A and P. Now in this case, if we find out that line equation in both cases, vector and vector form and Cartesian form. So first one, if we prove that vector form, so that's why what we are done in proof. So in proof, if you are done here, just what we consider from the diagram only, if you are done. So first here, if you are done, let A bar is the position vector. Let A bar is the position vector of a point A. Let A bar is the position vector of a point A with respect to origin O in rectangular system. So that's why what we have done here, OA bar is equal to A bar. OA bar is equal to A bar. Next, let L be the line which passes, let L be the line which passes through point A, and parallel to the vector B bar. Okay, ma? First A bar is the position vector of the given point with respect to origin. So that's why if next what, if we draw the one line, that line passes through the point A and parallel to the vector B bar. Next, let R bar be the position vector of the arbitrary point P of x comma y comma z with respect to origin O. Let R bar be the position vector of the arbitrary point P of x comma y comma z with respect to origin O. Okay na? And P lies on the line L, and P lies on the line L. Now here see what we have done here next. So position vector given means OP bar is equal to R bar. Now from this diagram what we observing here, AP bar is parallel to B bar. So that's why what we have done see here, AP bar means vector A is parallel to vector B. Already we know that parallel condition, AP vector is equal to lambda into B vector. Then how to write in with respect to position vectors form, OP vector minus OA vector is equal to lambda into B vector. OP vector is nothing but R bar. OA vector is nothing but A vector is equal to lambda into B. Now R vector is equal to what? A vector plus lambda into B vector. Okay na? Here any lambda value if we consider. So any lambda, for lambda belongs to R, this equation is represented. So this is the vector equation. This is the vector form of a line, the vector equation of a line. Okay na? So this is the vector form of a given line. Now what we put that here, Cartesian form there. Next in that the theorem only what there Cartesian form there. So that's why if we take here Cartesian form. So now if we prove that equation in vector form of a line, now what we prove that here, Cartesian form. So Cartesian form means if you run the coordinates of a point, what x1 comma y1 comma z1. Now this a point represent position vector, A bar is equal to x1 I cap, y1 j cap, z1 k cap. Okay na? Next coordinates of that values here ma a comma b and c are direction ratios of a line. So that's why what we done here, b bar is equal to a I cap, b j cap, c k cap. Next one ma, if you want to write that position vector r bar, coordinates of arbitrary point x comma y comma z. So that's why what we done here, r bar is equal to x I cap, y j cap, z k cap. Okay na? So first we take the coordinates of a point with respect to position vector. A, B, C are the direction ratios of a line. So that's why b bar, that is the vector direction represent the p coordinates, we represent the position. Now these values, which values ma? A bar comma b bar and r bar. Substitute in r bar is equal to a bar plus lambda into b bar. So these values are substituting in the above equation. R bar is equal to a bar plus lambda into b bar. So r bar is equal to what ma? X I cap, y j cap, z k cap is equal to this one ma? X1 I cap, y1 j cap, z1 k cap plus lambda into b bar vector what ma here? A I cap, b j cap, c k cap. Now we comparing the corresponding components of I cap, j cap, k cap on both sides. Then what we done see ma here? X I cap, y j cap, z k cap is equal to x1 plus lambda into a I cap, y1 plus b lambda into b j cap plus z1 plus c lambda into k cap. Now if we comparing the components of I cap, j cap, z k cap on both sides, then what we will see ma? X is equal to x1 plus lambda into a, x minus x1 by a is equal to lambda, y is equal to y1 plus b into lambda, y minus y1 by b is equal to lambda. Next z is equal to z1 plus c into lambda, z minus z1 by c is equal to lambda. From the above equation, if we eliminate lambda parameter, eliminate lambda from the above equations, then what we will see here? X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Now this is represent the Cartesian form of the line, Cartesian form of a line. Okay na? So this theorem is very important ma in board, particularly 5 marks question. So first one is vector form and second one is ma Cartesian form. Okay na? Let's see ma. Just now only we completed one theorem. Means what ma that one? Equation of a line passing through the point and parallel to the vector. There we learn ma Cartesian form. What we learn there? Cartesian form. X minus x1 by a is equal to y minus y1 by b is equal to ma z minus z1 by c. Now this is represent Cartesian form of a line passing through the point x1 comma y1 comma z1 and having the direction ratios. Okay na? Otherwise L comma m comma n or the direction L comma m comma n or direction cosines of a line. So except that a direction ratios he given direction cosines given. In this case, what is the equation of line passing through the point x1 comma y1 comma z1 in Cartesian form? What we done means here x minus x1 by L, y minus y1 by m is equal to z minus z1 by n value. Okay na? Same formula only, but instead of that direction ratios, if we replace the direction cosines, when we replace this one, particularly in a question he given the line having direction cosines and passing through the point, then we write on the Cartesian form of the given line equation, then if you write on this equation. Otherwise, so direction ratios only given means the first one only preferable equation for that given question. Okay ma? Right, Sima. Another theorem in that lines only ma. So equation of a line passing through the given 2 points. So if we derive the equation of line passing through the 2 points in both vector and Cartesian form. So this one also important question ma, 5 marks repeated question. So every year these questions are repeated questions ma, first theorem and second theorem in this lines topic. Okay na? So now here what given, now if you want to derive the equation of a line passing through the 2 given points in both vector and Cartesian form. So that's why if you want to draw the first diagram also important ma here. So first we take a rectangular coordinate system, means x axis, y axis, z axis. Okay na? Now if we draw one line, so this one, if we take points, here A point, now here B point, suppose if we take one arbitrary point P. Now if we join these points with horizon. So why you join with horizon ma? If you want here position vectors, so that's why. So this position vector A bar, this position vector R bar, this position vector ma B bar. Now this coordinates, already you know that this coordinates x1 comma y1 comma z1. So this coordinates ma x2 comma y2 comma z2, and this coordinates x comma y comma z, x comma y comma z. Okay na? So first we take 3 points on the line. So one line passing through the A comma and B, and if we take one arbitrary point on the line and we join that points with the horizon. Okay, now what we write on here, so this is the horizon value. Now if you want to prove that first vector form, Sima, in proof what we write on Sima here, steps. First we write on the position vectors A bar and B bar, means what we write on here, let A bar and B bar are the position vectors of the points A of x1 comma y1 comma z1 and B of x2 comma y2 comma z2. Okay na? A bar and B bar are the position vectors of the points A and B with respect to horizon, O. So that's why what we are going to see here, OA bar, vector OA is equal to A bar, vector OB is equal to B bar. Now if we take the arbitrary point, let R bar be the position vector, of the arbitrary point P of x comma y comma z. So let R bar be the position vector of the arbitrary point P of x comma y comma z with respect to horizon. Then what we run, OP vector is equal to R. Okay na? OP vector is equal to R. Now here Sima, what we run, now this P point lies on AB line. So that's why what we run, then P lies on the line, if and only if, when P lies on the line, if and only if, what we write Sima here, AP and AB vectors, AP and AB vectors, AB and AB are collinear vectors. Okay na? So when we take P point on the line AB, then must and should be these three become as which type of collinear, means how to AP vector and AB vector, these two are which type of vectors? Collinear vectors. Already we know that collinear vectors means how to run this one. AP is equal to lambda into AB. Now we convert into position vectors. OP vector minus OA vector, lambda into OB vector minus OA vector. Then what we run this vector here? R bar. This vector A vector, lambda into B vector minus A vector. Now finally what we run Sima here? R bar is equal to A bar plus lambda into B bar minus A bar. So this is represent. This is a here lambda if we take any real number. So this is represent what vector form of the given line. Vector form of the given line. Now here also if we prove that Cartesian form. Cartesian form. Okay na? Now if we take here these points given now, that position vectors what we run see A point given here, A of x1 comma y1 comma z1. Now this position vector if we consider A bar is equal to x1 i cap, y1 j cap, z1 k cap, and B vector, B point x2 y2 z2. So this is represent position vector B. Then what we run here? x2 i cap, y2 j cap, z2 k cap. Next position vector already given P. So that coordinates x comma y comma z. That implies R bar is equal to x I cap, y j cap, z k cap. Okay na? So first the given points we convert into position vectors. Now these values A bar comma B bar and R bar, substitute in R bar is equal to A bar plus lambda into B bar minus A bar. So these values are substituting in this vector equation. Then see in that vector equation, now if we replace these values, then what happened here? So R bar is equal to how much there here? X into I cap, Y into J cap, Z into K cap is equal to A bar. A bar is equal to what A bar is equal to x1 I cap, y1 j cap, z1 k cap plus lambda into B bar minus A bar. These two subtraction x2 minus x1. How much here? x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay na? Now here see R bar is equal to A bar plus lambda into B bar minus A bar. R bar, this value is equal to A bar. These two difference. Now if you run here what we run see that is equal to, otherwise this value taken on to this side, this equation. Then what we run here x minus x1 I cap, y minus y1 j cap, z minus z1 k cap is equal to this vector if we take on to this side and difference. Now this value is what here? Lambda into x2 minus x1 I cap, lambda into y2 minus y1 j cap plus lambda into z2 minus z1 k cap. Now again in this equation we compare in the scalar components I cap j cap. Then what we run here? X minus x1 is equal to x2 minus x1 into lambda. So x minus x1 by x2 minus x1 is equal to lambda. Similarly if you want to run y minus y1 by y2 minus y1 is equal to lambda. Z minus z1 by z2 minus z1 is equal to lambda. Now from the above equation if we eliminate that lambda value, from the above equation we eliminate that lambda value, then what we run here equation? X minus x1 by x2 minus x1, y minus y1 by y2 minus y1 is equal to z minus Z1 by Z2 minus Z1. So this equation is represent the Cartesian form of the line passing through the given 2 points. Okay, ma? So this is a vector and a Cartesian form of the given given statement, ma. So this is also very very important for 5 marks question. See, ma, here one example question there, ma. Find the vector and the Cartesian equation of the line through the point, one point, the line passing through the one point, and which is parallel to the vector. Already just I derived one theorem, first theorem. What means the equation of a line passing through the point and parallel to the vector b bar in vector and Cartesian form. Vector form what means r bar is equal to a bar plus lambda into b bar. Cartesian form what means x minus x1 by a, y minus y1 by b, z minus z1 by c is equal to there in between. So that is the Cartesian and the vector form. So that's why what we done these two means, ma. So first we take here point given, ma. Let the given point be a of 5 comma 2 comma minus 4. Now this position vector what we done here, a bar is equal to 5i cap plus 2j cap minus 4k cap. Here parallel vector b. So then 3i cap plus 2j cap minus 8k cap. Here what we done, equation of a line in vector form. Equation of a line in vector form is r bar is equal to a bar plus lambda into b bar. R bar is equal to a bar 5i cap 2j cap minus 4k cap plus lambda into 3i cap plus 2j cap minus 8k cap. Now this is represent the vector equation, means equation of a line in vector form. And Cartesian form if you want means what we require here, point x1 y1 z1, already given point x1 y1 z1 point given. What given point? So a of x1 comma y1 comma z1 is equal to a of 5 comma 2 comma minus 4, and direction ratios b vector given, nama. So b vector what given here, b bar is equal to direction given 3i cap 2j cap minus 8k cap. So from this vector a is equal to 3 and b is equal to 2, c is equal to minus 8 value, minus 8. Now directly if you run Cartesian form, otherwise if you forgot that Cartesian form is what we run generally these values, position vector and this b vector and a vector we substituting here, and general vector if you run r bar vector, position vector of the point p xy comma, then we simplifying, then automatically then also if we get the answer, but directly we know that this formula. So that's why what we run here, equation of a line in Cartesian form, equation of a line in Cartesian form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Sima, x minus 5 by a is equal to 3, y minus 2 by b is equal to 2. Okay, next z plus 4 by minus 8. Now these are the vector and the Cartesian equation of a line passing through the point and parallel to the given vector. Another example, ma. So find the equation, find the vector equation for the line passing through the points. So second theorem this one. So formula what, ma? Vector form formula r bar is equal to a bar plus lambda into b bar minus a bar. So he given 2 points given. Okay, na? So that's why what we run here, first here let a bar and b bar or the position vectors of the points a of minus 1 comma 0 comma 2 and b of 3 comma 4 comma 6. Now here see, if you assign this position vectors, so minus I cap plus 2k cap, b bar is equal to 3 I cap plus 4j cap plus my 6k cap. My here b bar minus a bar if you want to find out. So 3 minus means my 4I cap, 4 minus j not there, so 4j cap plus my 4k cap. Now already we know that equation of a line in vector form passing through the 2 points. Then what would be the equation of a line? In vector form is r bar is equal to a vector plus lambda into b bar minus a bar. Here r bar means what? R is the position vector of the point lies on the line. So r bar is equal to minus I cap plus 2k cap plus lambda into 4 I cap 4 j cap 4 k cap. Okay na? Otherwise if you want Cartesian form means formula what? X minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Already here points given x1 y1 z1 x2 y2 z. Directly we replace that points in that Cartesian form, then easily we get the equation of a line in Cartesian form. Right, so next concept angle between two lines. Just now only revise angle between two vectors, direction ratios given, direction cosines given. So same concept only, but here two lines given, then if you find out the angle between the two lines. Here see if we take two lines L1 and L2 and these two lines are passing through the horizon, Now if we take here, so direction ratios means first A1 comma A2, A1 comma B1, A1 comma B1 comma C1 or direction ratios of L1. So line 1 direction ratios A1, B1, C1. Next A2 comma B2 comma C2 or direction ratios of line L2. So first we take two lines, the two lines are passing through the horizon and two with the direction ratios A1, B1, C1, A2, B2, C2. Okay na? Now if we take any 2 points, suppose line 1 if we take point P, so line 2 if we take point Q, then OP and OQ are represent the directed line. Means what? That is nothing but a vector, so that's why P and Q, or if we take any 2 points on L1 and L2, now OP and OQ are represented the directed lines. So that's why what we are done here, OP directed line means the vector. So then what we are done here, A1 I cap, B1 J cap, C1 K cap, and again OQ is equal to A2 I cap, B2 J cap, C2 K cap. So actually what we require here, angle between the two vectors. So that's why if we take here, let theta be the acute angle. Let theta be the acute angle between L1 and L2. Then how to run here? On that line if we consider two directed lines there, So that's why what we run here, cos theta is equal to OP vector dot OQ vector by magnitude of OP by magnitude of OQ. Why if we take 2 points P and Q on the lines, now these two are become as a directed line, means that is a vector. Okay na? So that's why here dot product in between what we run here, A1 A2 plus B1 B2 plus C1 C2 by sigma OP. So then what we run here, A1 square plus B1 square plus C1 square. Again A2 square plus B2 square plus C2 square. So this is represent the cos theta, but we using the modulus here. So why we are using the modulus? Already told before only in vectors, if you want to find out angle between any vectors without if using modulus, there theta is particularly acute given, means then we take modulus, here acute given. So that's why we are applying the modulus value. So this is the formula. When the two lines having the direction ratios given, then if you want to find out the angle between two lines, then we find out this formula, cos theta is equal to modulus of A1 A2 plus B1 B2 plus C1 C2 by square root of a1 square plus b1 square plus c1 square, square root of a2 square plus b2 square plus c2 square. So if you want to find out first sine angle, same concept, then what we done here, sine square theta is equal to 1 minus cos square theta, and sine theta is equal to square root of 1 minus cos square theta. So by using this one, if you find out for cos theta, that value if you replacing here, then automatically easily if you get the sine theta value. And very important here 2 points there, already we discussed these points also. These two lines are perpendicular, these two lines are parallel. If L1 is perpendicular to L2, if L1 is perpendicular to L2, if line 1 is perpendicular to L2, then condition what we run here means angle between the two lines is equal to 90 degrees, cos 90, that value become as 0. Denominator if you taken on to this side, that value become as 0. Then condition what my here, a1 a2 plus b1 b2 plus c1 c2 is equal to 0 value. Otherwise, if L1 is parallel to L2, then condition what we run here, a1 by a2 is equal to b1 by b2 is equal to c1 by c2 value, c1 by c2 value. Okay na? So when this one, so if you want to find out the angle between any two lines having the direction ratios given, then automatically if you find out the cos theta value or sin theta value, or perpendicular condition or parallel condition. Okay na? Now same concept instead of that the two lines having the direction cosines, direction ratios given, then we find out this one. So direction cosine, L1 and L2 have the direction cosines, L1 comma m1 comma n1 and L2 comma m2 comma n2. Then what is the angle between the two lines? So means direction cosines of L1 or L1 comma m1 comma n1. Okay na? Next, so direction cosines of L2 or L2 comma m2 comma n2. Now theta, here also if we take one, let theta be the acute angle. Let theta be the acute angle between L1 and L2. Then what we will see here, cos theta is equal to modulus of, already we explained this concept in vectors also. Then directly if written here, L1 L2 plus M1 M2 plus N1 N2. So this is the formula for angle between the two lines. When the two lines have the direction cosines given, then we are applying this formula. Same concept. Sine also if you want means what we run 1 minus cos square theta value. Or another one the method there, if you remember this one, if you want to directly, this formula means sin theta is equal to square root of, in determinant form there, just we take here L1 M1 N1, L2 M2 N2. These difference right first here, L1 M2 minus M1 L2 whole square minus M1 N2 minus N1 M2 whole square plus N1 L2 minus L1 N2 whole square. So this is the sin theta formula. So determinant process L1 M1 N1 L2 N2 M2, right, and cross multiplication means determinant method we are applying, then if we get the sin theta. Here also same, L1 is perpendicular to L2, then what we run here, so L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Parallel means L1 is equal to L2, M1 is equal to M2, N1 is equal to N2 value. So this is the formula. Okay na? So another one then two line equations given, two line equations means like this given R bar is equal to A bar plus lambda into A1 bar plus lambda into B1 bar. Next, R bar is equal to A2 bar plus lambda into B2 bar. So two line equation like this given. Then if you want to find out angle between these two lines, here also if we take let theta be the acute angle, then if you find out the cos theta is equal to modulus of B1 bar dot B2 bar by magnitude of B1 bar into magnitude of B2 bar. Okay na? So R bar is equal to A1 bar plus lambda into B1 bar. R bar is equal to A2 bar plus lambda or mu. Anyone if you don't know, no problem. Mu into B2 bar if you taken. Then if you find out the angle between the two lines in this form given means cos theta is equal to B1 bar dot B2 bar. B magnitude of B1 B2. Why means already we know that this one what ma equation of a line passing through the one point and parallel to the vector. Here B1 vector and B2 are the vectors. These are the position vectors. So that's why if you taken here also condition there. In this these two lines are perpendicular. Then what we done B1 bar dot B2 is equal to 0. These two are parallel. B1 is equal to lambda into B2. So means what ma? Here two vectors are perpendicular. These two vectors are perpendicular. Condition what ma? B1 bar dot B2 bar is equal to 0. Parallel. Then condition what ma? B1 bar is equal to lambda into B2 bar condition. Okay na? So these are the angle between two lines. First case what ma? The line two lines having the direction ratios given. Then formula cos theta is equal to this one. Then the two lines having the direction cosines given. Cos theta is equal to L1 plus L2 M1 plus M2 plus N1 into N2. Otherwise here two equations, line equation like this given. R bar is equal to A1 bar plus lambda into B1 bar. R bar is equal to A2 bar plus mu into B2 bar given. Then angle means cos theta is equal to B1 bar dot B2 bar by magnitude of B1 into magnitude of B2. So these two lines are perpendicular. Then B1 bar dot B2 is equal to 0 and parallel means B1 bar is equal to lambda into B2 bar. So this is the concept of angle between two lines. Sima. So another point in angle between two lines only. So before we discussed Cartesian vector form given two lines. R bar is equal to A1 bar plus lambda into B1 bar. R bar is equal to A2 bar plus lambda mu into B2 bar. Then if you find out angle between two lines. Now the two lines given in Cartesian form means x minus x1 by A1 is equal to y minus y1 by B1 is equal to z minus z1 by C1. And x minus x2 by A2 is equal to y minus y2 by B2 is equal to z minus z2 by C2. Okay na? This is equation 1 and this is equation 2. Here see ma A1 comma B1 comma C1 and A2 comma B2 comma C2 are the direction ratios of equation 1 and 2 respectively. Equation 1 and 2 respectively. Okay na? So these are the line equation in Cartesian form given. These two lines have the direction ratios. So just now only we discussed them. Any two lines L1 and L2 have the direction ratios. Then what we find out angle between the two lines cos theta is equal to mod of A1 A2 plus B1 B2 plus C1 C2 by square root of this value sigma A1 square root of this value sigma A2 square value. Now this is the angle between two symmetric two line equation in symmetric form given. Then we using this formula and we find out the angle between the two lines. Right here Sima, find the angle between the pair of lines given by here vector form given. R bar is equal to A bar plus lambda into B bar. R bar is equal to A bar plus mu into B bar. But here Sima, find the angle between the pair of lines in symmetric form or Cartesian form given. Okay na? So then these two, how to find it variations? First we take this one. So example 1, here form what given R bar is equal to A bar plus lambda into B bar. So from that equation given that what we done here B1 bar is equal to vector I cap plus 2j cap plus 2k cap. Next B2 bar is equal to 3i cap plus 2j cap plus 6k cap. Now if you find out the angle between two lines, let theta be the acute angle between the given lines. So formula what my here? Cos theta is equal to modulus of B1 bar dot B2 bar by magnitude of B1 into magnitude of B2 value, that is equal to B1 bar dot B2 bar. So these two dot product. So 3 plus 4 plus 12 value. Correct? So 1 into 3, 2 into 2, 2 into 6, 12 value. So magnitude value is given. Magnitude value is given means what we done? First magnitude value of this value, how much we done here? Suppose first if you done this value 1 square, 1 plus 4 plus 4, 1 plus 4 plus 4, and second one So this value what given? 9 plus 4 plus 36 value. Now that is equal to, next what we have done here, 7 plus 12, 19 divides this value ma, here 9 means 3 value, 3 into, next this value ma 49, 7. So that is equal to 19 by 21. So theta is equal to how much ma here? Cos inverse of 19 by 21 value. So in vector form given, then if you write on this value, otherwise Cartesian form given, then what we write on Sima here? Cartesian form means x minus x1 by a, y minus y1 by b, z minus z1 by c. Now these are the direction ratios. Suppose if we given equation 1 and equation 2, so then what we write on here? 3, 5 and 4 are direction ratios of equation 1. And next one what ma? 1, 1 and 2 are direction ratios of equation 2. Now again here also if you take ma, let theta with the acute angle between equation 1 and 2. Then what we run here? Cos theta is equal to formula a1 a2 b1 b2 a1 a2 plus ma b1 b2 plus c1 c2 by square root of this sum sigma a1 square and ma sigma a2 square, that is equal to, here see ma these two product 3 into 1 3 value plus 5 value plus 8 divides ma this square value, first value 3 square 9 plus 25 plus 16 square root of 1 plus 4 value. Now see ma that is equal to, here how much ma 11 plus 5 16 by this root value how much ma 25 50 means what ma 5 into root 2 value. Now this value how much ma 6, so root 3 into root 2, root 3 into root 2, so 10 into root 3. So this one if you run ma 10 into root 3 means root 2, 2 1s are 2 8s are 8 into root 3 by 5 value, 8 into root 3 by 5. So that is the theta value ma, theta is equal to cos inverse of 8 into root 3 by 5 value. Here okay ma calculation. So root 6 if you run root 2 into root 3, so 2 value, 2 1s are 2 8s are, so root 3 denominator there no ma, sorry here 15, this value is equal to 15 ma, here root 3 by 3 5s are 15, so 8 into root 3 by 15 value. So this is the variation, vector form and Cartesian form if you want to find out the angle between the given two lines.